A solid vertical prismatic bar of steel of equilateral triangular section is having side of 25 mm. It is fixed at the top. A rigid collar is attached at the lower end at a distance of 600 mm from the top. Calculate the strain energy in the following cases: when pull of 10 kN is gradually applied, when force of 8 kN is suddenly applied, and third case is of the impact load, that is a weight of 4 kN falls through a height of 120 mm. Assume E is equal to 210 GPa. To convert GPa into MPa, we have to multiply by 10 raised to 3. So what we are having over here is that it is given that the bar is fixed at the top and a collar is attached at a distance of 600 mm from the top. So this is the distance from the top, that is of 600 mm, and the cross section of this particular bar is the triangular cross section. So this is the concept of this impact loading. So the load is falling on this particular collar from a height of 600 mm. So that is given in the example. Now let us first find out the value of H. Base is already known to us for the triangle, that is 25 mm. So we know that this angle is 60 degree. So as it is a equilateral triangle, all these angles will be of 60 degree. So tan 60 will be equal to opposite side, that is H, divided by the adjacent side, that is 12.5. So tan 60 is equal to H upon 12.5. So we are considering this right angle triangle, that is this particular triangle. So tan 60 will be equal to opposite side divided by the adjacent side, that is H upon 12.5. So H will be equal to 12.5 multiplied by tan 60. Now area of the triangular section will be 1/2 base into height. Base is 25 and height just now we have calculated as 12.5 multiplied by tan 60. So area comes out to be 270.63 mm square. In the first case, we are having a pull of 10 kilonewton which is applied gradually. So maximum instantaneous stress developed is force upon area. So it is 10 into 10 raised to 3 divided by area which we have just now calculated. So we'll get the value of maximum instantaneous stress as 36.95 MPa. Now we have to find out the value of strain energy also, which is sigma square divided by 2E into volume. Volume is area into length. So in place of sigma, it is 36.95, 2 as it is, E 200 into 10 raised to 3. Volume is area into length. So here the units are Newton per mm square and square of that. E is having the unit of Newton per mm square. Area is in mm square, length is in mm. Area is 270.63 and length is 600. So we'll get the value of U as 527.85 Newton mm. Now for suddenly applied load of 8 kN, we know that maximum instantaneous stress is given as 2 times W upon A or force upon area. So that is P upon A. You can use any notation over here. Either you can say 2W upon A or 2P upon A. So it is 2 into value of P is 8 into 10 raised to 3. Area is 270.60. So that value is 59.12. And again use the formula for strain energy, that is sigma square upon 2E into volume. Volume is area into length. So that is same for the previous as that of the previous case. Only the value of sigma is changing in each of the cases. Rest of the values are remaining same. The value of U will be 1351.28 Newton mm. And finally, when you consider the case of the impact load, a weight of 4 kilonewton is falling through a height of 120 mm. So W is given as 4 kilonewton. Convert kilonewton into Newton by multiplying by 1000. H is 120 mm. Sigma max in this particular case is given by W upon A plus or minus square root of 2WHE upon AL plus W square upon A square. Value of W is 4000, area is 270.63. We'll consider plus sign for the maximum stress so that the design will be a safe design. W is 4000, H is 120 in this particular case because height is given as 120 now. E is 210 into 10 raised to 3. Area is 270.63 into 600 is the length. W square upon A square. So it is W upon A and the square of that. And if you make this calculation, then the value comes out to be 1129.125 MPa. So strain energy will be equal to sigma square upon 2E into volume. Just substitute the value of sigma 1129.125 and square of that. The rest of the values are same as we have done earlier. So area into length is the volume. So you'll get the value of U. So value of U comes out to be 492.9 Newton mm into 10 raised to 3 Newton mm. Now if you divide this by 1000, it will get converted to Newton meter, that is joule. So it is as good as 492.9 joule or Newton meter.